Hey guys, so today I'm going to be explaining voltage regulators, the standard kind like the 7805s, 7812s, whatever, and LM317Ts, and how to use them and such, and just a really simple tutorial for beginners who just want to get a clean 5 volts output or in the LM317 case, a clean whatever volt you want output. So this is the way the 7805 or 7812, 78 whatever will usually be denoted in the circuit diagram. Okay, in a schematic. You'll have a little box. Usually it won't be without the numbers. Usually, like right here, you'll just have a little box with 3 legs sticking out of it. This first leg here, that's your input, okay? The second leg coming out of the bottom, that's your ground. And then the third leg to the right, that's your output, okay? So, but you got to make sure for this ground is that the input, the ground of the input circuit and the ground of the output circuit are connected. It won't hurt the circuits at all. It will just make, if it's not, the voltage regulator won't work. So remember, if you have your input, you have your ground on your input, and you have your ground on your output, you got to make sure those two grounds are the same. So as in, like, if your input is the, say, a wall transformer, you got to make sure that ground is hooked up to the ground of, say, you're using it for an Arduino. You got to make sure those two grounds are connected, and then the ground for the 7805 is connected to that. And so as you can see, we have 1 is the input, 2 is the ground, and 3 is the output. Okay, 1 input, 2 ground, 3 output. And then this is the way the pins will usually work, is that the leftmost pin will be pin 1, the input, the second pin will be the ground, and the third pin will be the output. So if we get our 7805 here, we match it up. It's not quite as big as my drawing example, but you can see there's still 3 pins on it. So we're going to jump over to our breadboard here. And remember, the input has to be at least 2 volts higher, I would say, is a good reference. So we're just going to take our 7805, plug it in. Okay, we're going to connect our ground. Okay, here maybe I have to move this camera. One of the disadvantages of using a tripod is that it's not very flexible, as in, you know, turns it like, no, that's too complicated. You should be able to see all the rows. Okay, so it's connected to these 3 rows here, okay? Row 30, row 31, and row 32. Okay. Can you see that? My camera really hates to focus. Okay, whatever. Anyway, row 30, since this is pin 1, if you remember, pin 1 is our input. So we're just going to connect a wire to that I'm going to hook up to the input of my power supply. Okay? So that is going to be hooked up to the input of my power supply. Alright, now it is. Okay. So now what we're going to do is we're going to take the second pin, okay, which is on pin 31, and we're going to hook that up to my circuit ground, which is going to be the ground rail. Pretend whatever my circuit is, which I don't have one right here, but whatever it is has its ground hooked up to this the first blue ground rail here. So this one, okay. So then we're also going to have a wire that's going to connect it to the ground of our power supply that is at least 2 volts higher than 5 volts. In my case, it is 12, okay? Now, on the third pin, which is, you got to make sure at this point, though, it's not heating up, okay? That's pretty important. The third pin now, in this case, should be connected, should be, in theory, connected to, it doesn't really have to be connected to anything for it to work, but right now it's going to be connected to our circuit's power rail, so that now our circuit can be getting the 5 volts of power that it needs. So remember, these 2 grounds are connected. This is our input, and then right here, this is our output on this power rail, okay? On this first red power rail. So if we take our multimeter, how am I going to get this all in one shot? Might be able to do it. Might be a bit weird, but let's see. Okay, so those 2 wires right here is for my power supply, and then my multimeter is displaying it in volts. So So we're going to hook this one up to the ground, because remember, both grounds are the same. So that's just connected up to the ground. And if that one's connected up to the output, we're getting a solid 4.8 volts. And remember, these things don't have really high tolerances, but 4.8 volts is just fine for your microcontroller. It will handle it just fine. So there we go. That's really simple how to set up a linear regulator, just a regular type. Now we're going to get into something a bit more complicated than just a simple linear regulator. We're going to get into the LM317T, which is an adjustable regulator. I mean, you can make it give any voltage you want. Okay, so this is the way you'll commonly see the LM317T, or just regular LM317. Looks like this. This is the one I have. They all come in these TO220 packages. They make heat sinks for them. One sec, let me get mine. Yeah, not now. I lost it, but yeah, it's probably in a box somewhere. Anyway, this is it. You can get heat sinks because they will heat up if you pull more than a couple hundred milliamps out of them, like 200 or 300. But anyway, on the left you'll see the voltage input that you give it. The middle you'll see this adjustable pin, and the left this is the voltage output. Okay. Now just remember that unlike the regular regulator, is not the way you'll see the pins in the same order. This is not going to be pin 1, pin 2, and pin 3. If this is your LM317T here, just like we'll put the real one next to it, the leftmost pin, at least on mine, I'm assuming this is pretty standard, but yeah, I think it is, but you know, make sure to always look at the data sheet. The first pin is going to be the adjustable pin, the second pin is going to be the voltage out, and the third pin is going to be the voltage in. So just remember that these aren't, the first pin isn't voltage in, the first pin is adjustable. Okay, and this is kind of really an example circuit if you want to test it out. You take your input, ideally you should have a capacitor on the input and the output, you don't have to though. And you take your adjustable pin and you give it a 5K pot to ground, and this is the same ground thing that we talked about with the other one, is that the ground from the input has to be connected to the ground of the circuit that it's outputting to. You connect that to ground, and then and remember, since this is your voltage in, this is your adjustable, this is your V out. So your adjustable, a 5K pot to ground, and then your V out, a 240 or 220 will work also, ohm resistor. You connect that to the adjustable pin, and then as you spin the potentiometer, it will vary your voltage. So we're going to build something like that here, except I don't have the potentiometer. So instead we're just going to build a fixed power supply using a 1K and a 330 ohm, and ideally it should be, again, I think it's 5 volts, or either that or 3.3. But you can look online for these. Just go to Google, type in LM317 calculator, and then you can choose your 2 resistor values, and it will tell you your voltage out. But be careful though, this is ideal circumstances, so with no load. And remember, if you get a voltage out like 9 bajillion volts, right, that is not really a possible voltage, considering these things have a maximum input of about 30. So, remember the first pin is adjustable, and in our circuit diagram we had, you gotta keep the adjustable value pretty low. So, this is it. Our first pin is adjustable, and that is if in our circuit diagram, adjustable is connected to the V out. So, adjustable here, and this is going to be the V out. So, if this first pin is adjustable, right, you can see on this 330, and the second pin is V out. Now there's a 330 ohm resistor between adjustable and V out. So if we plug it in like that, now there is. And on the adjustable pin, which is pin 1, there's a 1K to ground. So for this one, our ground isn't going to be the power rail. Our ground is going to be one of these rows down here. I'm not sure which one. This is going to be whichever one the resistor really goes into. Alright, no, that one's too big. Okay, so now we have a 1K resistor from adjustable to that row right now is going to be our ground. And we also have a 330 from adjustable to V out. Okay? Our V out is going to be where we're going to measure our voltage. So we'll put an orange wire on V out. This is where we're going to connect our multimeter up to, as you can see, V out. That's the same place where this orange wire here is where we're going to connect our multimeter up to measure the output voltage. And then the next one is going to be VN, so the pin most to the right. So we're going to take this wire, and this is going to be hooked up to our VN. And then we're going to take a green wire here, and we're going to hook it up to our ground. So this is our ground. This is where the green wire is where we're going to measure our voltage from. So if we take this, we put it on VN, and we take this, and we put it on ground, and always a measure. If something starts to get really hot, disconnect it, and yeah. So this is a good example circuit to try out. But yeah, if it starts to heat up or anything, stop it immediately. So I'm going to connect the ground to my multimeter to green, and the output and my the volt side to the orange wire, and can you see that very well? Okay, anyway. As you can see, it's reading. Oops. Probably came out disconnected. Okay. It's reading 5 volts, okay? So, the way I did that was. Oops. Okay, the way I did that was the first pin has a 1K to ground, the pin 1, that's adjustable. The first pin is also connected via a 330 ohm resistor to the second pin, which is voltage out. The voltage out pin is also where I measured the voltage from. And the third pin is connected to the voltage in, or the 12 volt input that we're getting. And that's how to use the LM317Ts, or just LM317s. I'm out of time, so bye, comment, rate, subscribe, hope you like the show, and this file is